Quadcopters and helicopters achieve flight in very different ways. Sure, they both hover around, but a quadcopter only has 4 moving parts and is very mechanically simple, whereas a helicopter is very mechanically complex with its adjustable rotor head and tail rotor. There's an interesting balance between the two where you can have a really mechanically complex flying helicopter and a really electronic complex flying quadcopter. But what if you can make a helicopter with the mechanical simplicity of a drone? This video is sponsored by KiwiCo. More on them later. A few years ago I came across a video posted to the Mod Lab YouTube channel from the University of Pennsylvania. And it was of a research project carried out by Jimmy Paulos in Professor Mark Yim's lab. This thing was controlled using just 2 counter-rotating propellers. Nothing else. Jimmy's aerial vehicle achieves the same control with just this simple hinged rotor head. No extra servos, no solenoids, just a freely hinged rotor head and a very, very clever motor control system. As the speed of the motor is increased, the rotor blades lag behind, which causes the angle of one blade to increase and the other to decrease, achieving the same control as a helicopter rotor head. This just blew my mind that he could get similar control to a helicopter rotor head by speeding up and slowing down a single motor. Ever since I saw this video, I had to make one. So let's give it a go. So I purchased a brushless drone motor and attached a diametric magnet to the bottom of its shaft. Diametric basically means it's magnetised across its diameter, rather than on either face. I then attached the motor to a 3D printed mount, which allowed close mounting of a magnetic encoder. This accurately measures the exact angle of the motor, and from this I can calculate its speed. In order to achieve the same helicopter-like control that Jimmy's motor could, the motor needs to accelerate and decelerate at least twice per rotation. This motor is spinning at 2000 RPM and is slowed down 60 times. One rotation takes 33 milliseconds, which means it completes 5 revolutions in the blink of a human eye. So it can't be manually controlled. I wrote a short bit of code that applies a sinusoidal wave to the throttle signal, effectively increasing and decreasing it by 75% each rotation, which sounds like this. And looks like this. When put next to the regular spinning motor, they both complete a full rotation in a similar time period, but one is going from near standstill to near 4000 RPM every rotation. The next step was to make the rotor head with the angled hinges. As you can see, if I move this blade grip forward, the angle of attack increases. And if I move it backwards, the angle decreases. The reverse of this occurs with the other blade. But when I mounted the rotor head onto the motor, I didn't see any significant pitch changes throughout the rotation. This is because as the blade rotates at such a high RPM, their outwards force increases the friction at the hinges, so much so that they refuse to move. A few redesigns of the rotor head later, and it looked a little more promising. The next step is to build the helicopter, which will be manufactured from carbon fibre to keep the weight low and reduce load on the motor. This needed to be cut underwater to reduce any airborne dust, which isn't great for filming a video, but will look good once finished. Then the 3D printed frame parts were added, as well as the electronics. Because this helicopter only has 2 motors, it's relatively simple in terms of wiring, but there are quite a few electronic components that need to work together. And this is why you never mount propellers before plugging something in for the first time. I then added a small motor to the end of a tail boom to counteract the torque from the main rotor, as well as providing yaw control. Then attached a 3D printed rotor head and some landing skids, and it's ready for a first test. I think I might need to make some changes to the code. Let's talk about helicopter physics. This part of the helicopter rotor head is called a swash plate, and it basically controls the pitch and roll of the helicopter. If I push forwards on the controller, you see the swash plate tilt forwards. And you probably also notice that the pitch on the blades barely changes. That's because what this actually does is changes the pitch of the blades at 90 degrees to the axis that you want to move. This is because gyroscopic precession delays the rotation of the helicopter 90 degrees from when the maximum pitch angle occurs. But what happens if I do the same movement to the helicopter without a swash plate? Nothing. This is because all of the control is done in software, and you could almost say that it has a virtual swash plate. But if I do the same manoeuvre when the blades are spinning, you can see that the motor accelerates for the first 180 degrees and decelerates for the next 180 degrees, causing the blades to lead and lag at the perfect positions. Also bear in mind that this is happening at 3000 RPM, so these blades are swinging back and forth 50 times per second, which makes it very difficult to control, but not impossible, as Jimmy has proven. So I kept tuning the code and making small tweaks to the rotor head, until it still amazes me that this thing can actually fly with such a basic, freely hinged, 3D printed rotor head. It doesn't fly quite as well as an actual full helicopter rotor head, as this one can control both of the blades individually and simultaneously, which means it not only has pitch and roll control, but it also has collective pitch control, which means it can actually fly upside down. So this is essentially just a fixed pitch helicopter with limited control. I found that if there's any kind of wind or the helicopter isn't perfectly balanced, or if you do lots of really hard flight maneuvers, the motor does seem to get quite hot very quickly. Having said that, for a small, lightweight and cheap aerial vehicle, it works really well. As you can probably guess, I produce these projects to try and share my interest in engineering and making things, and hopefully inspire some of you to try the same, which is also the aim for the sponsor of this video, KiwiCo. They create super cool hands-on projects to expose kids to concepts in science, tech, engineering, art and math. Each kit is designed to be educational and, most importantly, fun. The kits provide everything you need, so there's no need to visit the hardware store, as well as a very well laid out instruction manual that explains how each component works. Sometimes the best way to learn is by being curious, and building your own projects will achieve just that. I mean, until building this kit from KiwiCo, I had no idea how to make a speaker for my phone. Aircraft can be powered by storing energy in many different forms. To keep kids excited about learning and reduce summer brain drain, what better way to do it than with KiwiCo crates? They offer 8 different crates designed for different ages and interests, which can be delivered via subscription. Or if you visit the KiwiCo store and see a project you really want to build, you can pick it with no subscription needed. Viewers of my channel can get 20% off everything from KiwiCo by visiting kiwico.com/Tom Stanton. I'll be posting a link in the description down below, or by using the promo code TOM20 when checking out. Thanks once again to KiwiCo for sponsoring this video. Thank you very much for watching, and if you enjoyed the video, it'd be great if you could leave a thumbs up down below. If you're new to my channel and want to see more projects similar to this, then please click subscribe down below. A massive thank you to all of my supporters over on patreon.com. You guys make these videos possible, and I honestly couldn't do it without you. Thanks once again for watching. Also, if you haven't clicked off the video just yet, I'll be posting links to all of Jimmy's work down in the description down below, to all of his research papers and also the Mod Lab videos. Also, I will be doing a deep dive into all the behind the scenes stuff, like how I coded this helicopter, etc., over on my second channel, which will also be linked in the description down below. So go check out all those links, and I'll see you in the next video. Goodbye.